You've probably heard the term serverless and wondered, how can there be no servers? What if I told you that it's a lie? Instead, it's more like no servers for you to manage. This concept means that someone else, like AWS, manages the servers for you, allowing you to focus on your application logic and not server maintenance. Let me guide you through this and introduce you to a powerful service from AWS, Lambda functions. AWS has a shared responsibility model. If you use services like EC2, which is like a virtual machine in the cloud, you handle tasks like setting up the operating system and network setup. When people talk about serverless, most likely they think about the AWS Lambda service. AWS Lambda is what we call an event-driven serverless compute service. In simple words, it runs your code when something specific happens. That could be a data change in DynamoDB, an HTTP request via API gateway, or a new message in SQS or SNS. And for AWS Lambda, the responsibility model shifts. You focus on your code, how Lambda should be configured, for example, how much memory it needs, and which resources it can access. AWS handles the rest, including server maintenance. So while servers exist, you don't need to worry about them. At the heart of AWS Lambda's functionality are its triggers. These triggers, or events, prompt Lambda to execute your code. They can be data changes, HTTP requests, file uploads, scheduled events, or notifications from services like Amazon SNS. The beauty of AWS Lambda is its flexibility. With AWS services and third-party platforms, almost any event can be a trigger, creating dynamic and automated applications. In addition to its flexibility, it provides some other benefits. It's cost-effective. You're built only for the milliseconds your code runs and the number of times it's executed. Plus, AWS offers 1 million free invocations per month. Secondly, you don't have to stress about scaling. It does that for you automatically. It also has a built-in fault tolerance. Lambda maintains compute capacity and infrastructure reliability. As I already mentioned, there is no server management. AWS handles server maintenance. If you want to allocate a certain amount of memory to your function, flexible resource model comes to rescue. Note that change in memory allocation also proportionally increases or decreases the CPU power. And last but not least, Lambda works seamlessly with many AWS services. To illustrate Lambda's versatility, let me share a personal project. I wanted an efficient way to track where my time goes without having to click a lot of buttons in an app. The idea? Simply send a text describing my current activity to a designated number and have it logged automatically. I turned to Twilio, a well-known messaging platform. After a quick setup and utilizing their initial free credits, I was ready to roll without any out-of-pocket expenses. Here is a brief overview of the workflow that I had in mind. I sent a text to the Twilio phone number. In Twilio, I've set up a webhook to execute a Twilio function when it receives a text message. This function then sends a message to an SQS queue I've set up in my AWS account. I also have a Lambda function, which gets triggered when there is a new message in the SQS queue. It, in turn, processes the message, extracting the details I care about, and stores these data in a DynamoDB table. Now, think about challenges you face daily. Can AWS Lambda with its myriad of triggers be your solution? And if you want to learn how to create a Lambda function with one of its triggers, then watch the next video.